Higher order functions in Python. A function is called higher order function if it contains the other functions as a parameter or returns a function as an output. That is, the function that operate with another function are known as higher order functions. So in its simple way, since in Python everything is an object, so that's why we call the functions as first class objects in Python. So we can pass a function as a parameter to a function and return the function as well. So if a function can allow the another function as a parameter to it and return a function, then that function is termed as a higher order function. So let's use a simple example to understand the scenario. So we create a simple function, say summation. This function is having two parameters. The first one is the n and the second one is a function, let's say name is square. So what actually we want? We want our summation function should return the square of n numbers. If we pass n as 3, it will return us square of 3 numbers, 1 square plus 2 square plus 3 square. And if we pass the value of n to 5, then it will return the square of 5 numbers, 1 square plus 2 square plus 3 square plus 4 square and 5 square. So that's it. So for that, to compute the sum of a square, we define a variable total initially to 0 and then we will iterate through a for loop. So for num in range, and this should start with the value 1 since we want the square 1 square then onwards, and then n plus 1 so as to include the n. Now we write the expression as total is equal to total plus square and then square of num. So in the first iteration it will compute 1 square, and in the next iteration it will compute 2 square, in the third iteration it will compute 3 square, and so on till n. And finally when this loop terminates, we like to return total. Now we need to define our square method as this will take a single parameter, say n, and this function will return square, that is n into n. So once this is completed, now we need to write the driver code. We simply call our print method summation, and then we use the value of n, say 3. So this should return me 1 square plus 2 square plus 3 square. So 1 plus 4 plus 9, that is 14. So let's check, it's fine. So in the similar way, we can define so many functions, like we can define the another function as well, like cube, and this function can return us the cube value. So return the cube of the number, like n into n into n. So in the similar way we can call in this same statement, like square is this value, then comma, and again we can use another value as well, that is cube. So here we need to call the cube function. So when we call through this cube method, it will return us the cube of the method, and when we call through the square method, then it will return the square of the method. Now what is more important is, in the calling time, if we are using here the cube method, then it will use the cube method, and then if we are using here, you can see that the square value is 1 square plus 2 square plus 3 square, that is 14, and then the cube value is 1 cube plus 2 cube, that is 8 9, and then 3 cube, that is 27. So 27 plus 9 is 36, so it is returning the exact value. So this summation function is called a higher order function, as it uses another function like square and cube in its parameter. So that is why this function is called a higher order function. Now the next one is the lambda expression. A lambda function is a small anonymous function. A lambda function can take any number of arguments but can only have one expression. So in simple words, when we have a single expression for a function, then it is better to design a lambda expression rather than creating it as a function. So lambda function can take any number of arguments, but in the definition part there is only single expression. So you can see here, as the example of a square, you are creating a lambda function which will have one parameter x, and it will return the square of the number, and when you call the function square with 5 value, it will print you the square of 5, that is 25. So we can check here. So let's say we define a function square and then the lambda expression. So lambda expression, n is the parameter and square means n cross n. So now when you call the print function with value 4, this will return 4 square, that is 60. So this is a simple expression. So lambda function can take any number of parameters but can use only one expression. Now map, filter and reduce function, these are all the higher order function, as they allow the other function as a parameter in its definition. So map, filter and reduce are the built-in functions of Python. The argument passed to these functions are the only factor that decide upon the output. So these three functions are of different types which will perform different type of operations, and it only depends upon the arguments or the parameter that will decide the output. So let's go one by one, starting with the map function. The map function takes another function as a parameter along with a sequence of iterables and return an output after applying the function to each iterable present in the sequence. So this map function is having two parameters. The first one is the function itself, the functionality that you want to perform, and the second one is the data set, that is the iterables on which you want that functionality to be performed. So in this simple example, you can see you are using a new function that will return the square of a number, and in the next line you are simply applying the map function to new function with a tuple having values 1, 2, 3 and 4. So since the new function is simply return you the square of a particular number, so this map function applying to new function with the iterable 1 2 3 4 will return you the square of each element. So if you run this function, let's design the function. Let's say we define a function, new function. This function is having a single parameter, and this function task is simply return the square value, that is n cross n. Now let's design the map function. So we are using the map. There are two parameters. The first one is the function itself. So in the function part we write here at new fun, comma, in the data part we supply here a tuple 1 2 3 and 4. Now if you print x, you will find the map address, the object address, but since you want the value what is exactly applied, then in that case you need to convert this into a set. So let's convert the reference to it set. Now you get, so this will return you the square of each element, that is 1 square plus 2 square plus 3 square plus 4 square. And since we are converting it into a set and the order is not important in a set, that's why the set is an unordered entity. So we are getting here the square of the each number, but the order is not fixed. And if the order is important, then you can convert it into a list. Now if you convert it into a list, then you find exactly the same order, the square of each iterable. So our map function uses two parameters. The first one is the function and the second one is the data itself. So now what makes power to our lambda expression is that when the lambda function is used without a name, that is the anonymous lambda function. So in this map function also we can apply the function parts with a lambda expression. So let's convert this function into the lambda expression. So we write here as lambda, say x, or say n cross n. So exactly the functionality of the new function is converted into the lambda expression, that is the anonymous expression or a function without the name. So whatever parameter is passed to the lambda function, it will return the square of that function. So again, when you run this particular function, you will find the same output. So this gives the power of the lambda function when this function is uses without any name, that is anonymous function itself. So that's why a map function is called a higher order function, since it uses another function as a parameter to itself. Now the next one is the filter function. The filter function is used to create an output list consisting of values for which the function returns true. So in the filter function, this function is also a higher order function, and this will return you the filtrate. That is, you must apply a condition or a criteria to your data, and for the criteria to be validated, so whatever data is validated through the criteria, this will return only that data, that is the filtrate part. So the syntax is the same. Filter is the name of the function, then the functionality, whatever functionality you need to perform, and then the data is passed as a iterable. So let's try to use the filter function. So we can use here with the lambda expression also. Let's say we use an expression that is n greater than 3. So this will work only for n greater than 3, not for 1, 2 and 3. This will work only for the 4. So now check what this function is performed. So you will find here, since this filter function filter the data based on the conditions, and in this case our condition is n should be greater than 3, so it bypasses 1, 2 and 3 and return only the filtrate part, that is the 4. So you can design a filter function in so many ways. The first part should be a function and the second part is the iterable or the data on which you need to perform that function. So in the similar way we can use the reduce function as well. The reduce function, as the name describes, applies a given function to the iterables and return a single value. So in this simple example, you need to import the reduce function from the function tools, and this function is applied to one by one. This function is applied to one by one from the beginning to the end. It pairs the two entities and perform a functionality. In this example, you can see here, the lambda function takes two parameters a and b and return the sum of a and b. And in the iterable part, you are providing a list as 23, 21, 45 and 98. So in the first phase, as the functionality is a plus b, it applies on 23 and 21. It will return the sum, that is 23 plus 21, that is 44. And then it will again reduce to 44 and then it added to the third element, that is 44 plus 45, that is 89. And then again it applies to the next element, that is 89 plus 98, that is 187. So finally it will return you 187. So reduce method is simply based on the functionality, apply on a data and reduce to a final result. So we can change here as reduce method and we can apply the functionality. Like if you want the same functionality, you can pass a and b are the two parameters, and in the functionality part it simply added both the parameters. So now here we are using a list, that is 23, 21, 45 and 98, then 45 and 98. Now we need to import also from import the reduce. Now if you run this function, there is a type problem, the object is not iterable, the int object, okay. Now it's fine, it takes two parameters. What is the problem here? Now it will return the value 187. Since this will return your integer value, it's not need to convert it into the object, that is the list, the constructor need not to be used here. So this will finally return you a single value, and this will reduce this iterable based on the functionality given in the first parameter. So reduce is also a higher order function. Now the thumb rule for these three methods: if you already have a list of values and you want to do the exact same operation on each of the element in the array and return the same amount of items in the list, in these type of situation it is better to use the map function. So the map function is advisable if we have a list of values and we want the same operation to each and every element, then it is advisable to use the map function. Now, if we have a list of values, but we want to apply a certain condition or a criteria to our list, then it is advisable to use the filter method. Now, the third case, if we have a list of values, but we need to compute some regressive operation on each and every value and finally computed a result, then in that case, based on the functionality, we use the reduce method. This method uses two parameters. The first one is the functionality and the second one is the data on which we need to perform that functionality. So that's all regarding the higher order function. Thank you.